Hello to all, myself Darpan Sluja. I am computer programmer. In this video, we will discuss about radical equation, absolute equation and inequality. We will start our discussion with equations with radicals. Radical expressions are mathematical expressions that contain square root, cube root, fourth root, fifth root or etc. Cube root of, for example, 64 is represented by radical in this form. 3 cube root of 64 is equal to 4, or an equation with radical is x is equal to under root x plus 6. To solve this equation with radical, we square both sides and after that we will get the result x is equal to 3 or x is equal to minus 2. The result x is equal to 3 is okay when we substitute the value of x is equal to 3 in this equation. We get the result okay, but when we put the value of x is equal to minus 2, result is not okay. So the original equation has a single solution, x is equal to 3. Now check how Sympy deals with the equations with radicals. So start with work. We first of all import all the function from Sympy package. Then we have created the symbols or variables. After that we have turned on the pretty printing by calling init printing method. So let's see cube root of 64. How to do that? Expression is equal to, for example, x and rational 1, 3 and then printing expression. So first of all import all the functions and it is cube root of x. If we want to check the cube root of 64, then 64 and rational 1 by 3 and we will get the answer 4. Now let's see next example. Next example is x is equal to under root x plus 6. So our equation is EQ is equal to EQ square root x plus 6 comma x, check it, and under root x plus 6 is equal to x. Now solve EQ comma x and we will get the answer 3. Now if we want to check whether the answer is right or wrong, we can call the function check solve, in which we will pass the value of variable in a dictionary x colon 3 and it returns us true. That means value of x, if substitute in this equation, we will get true. That means okay. Now this is the equation with radicals. Next topic is inequality. Inequality says that one side is either greater than, less than, equal or from other side, that is left hand side and right hand side. Here z minus 5 is our left hand side, that is less than equal to 4z. When you put the value of 1, you will get the true answer. Let's check it. Expression is equal to z minus 5 less than equal to 4 into z and expr, shift enter. This is our equation. Now substitute the value of z is equal to 1, expr dot subs z comma 1, shift enter, and this is true. So our inequality is true when we put the value of z is equal to 1. Next thing is linear inequality. What is linear inequality? This is our linear inequality. So now if we want all the solutions for this linear inequality, first we will turn it into polynomial inequality. So our expression will become, that means polynomial inequality means right hand side will be 0. So expression is equal to expression, first of all poly expression dot left hand side minus expression dot right hand side. Shift enter. Expression. Shift enter. Expression dot left hand side is minus expression dot right hand side. So here we will take P1, shift enter. Poly object has no attribute LHS. Our expression is this, and now it is minus 3 z minus 5. That means z minus 5, and we take the right hand side to the left hand side. By subtracting it, that it will become z minus 5 minus 4z, that means minus 3z minus 5. Now polynomial, we will check the polynomial inequality by calling the method solve poly underscore inequality EQUALI, inequality of polynomial P1, and our relational operator is less than sign, that is less than equal to. Now the equation become minus 3z minus 5 less than equal to 0. So here we are checking our polynomial inequality, which says that from minus 5 by 3 to infinity, this bracket means including the value of minus 5 by 3 comma in to infinity, all value will satisfy this equation. Here we can say that, remember that bracket, square bracket means that we include the endpoints, while a parenthesis means we don't include the endpoint. Here we can see that from minus 5 by 3 to infinity, all values will satisfy this equation. So to get all the values for a linear equality, first convert it to polynomial inequality, means to say that all right hand side value you will take to left hand side, so that the equation will become less than equal to 0 or greater than equal to, so that right hand side will become 0, and now it is a polynomial. After that we can call solve poly inequality function to get our equation. Next example is 2 1 minus x plus 5 is less than. So this is our linear equation. First convert it to polynomial. So for that we have our expression EXPR is equal to 2 into 1 minus x plus 5 less than equal to 3 into 2 into x minus 1 EXPR. So our equation will become 7 minus 2x less than equal to 6 minus 3. Now convert it to polynomial. So our polynomial P1 is equal to poly, take the right hand side to the left hand side. So our expression will become dot LHS minus EXPR dot RHS and P1. So this is our equation will become. Now our equation says that minus 8x plus 10 is less than equal to 0, because right hand side will go to left hand side and there is now only a 0. Now solve this equation by calling solve poly inequality method. So our answer is 5 by 4 to infinity. So all these value from 5 by 4 to infinity will satisfy this equation for this inequality. Next example is, we take EXPR is equal to minus x plus 4 less than 0. So it is our already a polynomial because the right hand side is a 0 expression. So expression 4 minus x less than 0. So convert it to polynomial. Poly p is equal to poly dot LHS. There is no right hand side, comma x, and call the polynomial inequality function for less than 0. So we will call the function here solve poly inequality. Shift here is P1, shift enter, 4 up to infinity. 4 is not included. If you include, here is our parenthesis which says that this value will not be included. If you take this value, 4 minus 4 less than 0 is not true. 5 minus 4 minus 5, that is minus 5 less than 0, yes. 6 up to infinity, all values satisfy this inequality equation. This is simple equation, and from this you can get your answer. For rational inequality, we have already discussed in our video, but here we will take a single example to revise all the previous things. X is equal to symbol. What is rational expressions? Rational expression is an algebraic expression in which the numerator and the denominator are both polynomial. Here is an example of rational inequality. X, our expression is equal to x plus 1 divided by x plus 2 greater than 0. Expression, shift enter, x plus 1 divided by x plus 2 greater than 0. Okay, symbol S, x plus 1. So this is our rational inequality. Take the numerator and denominator polynomial from this equation into two variable numer and denom is equal to LHS from our left hand side. Right hand side is 0 as our numerator polynomial is LHS of expression LHS as x plus 1, and then we have our denominator x plus 2 and our relational operator REL is equal to EXPR dot relational operator REL underscore OP REL is greater than 0. This is our relational operator. Now we will call the function solve rational inequalities and pass our values, that is and the relational operator between them. For efficiency reason, poly should have been a polynomial instance. So The error says that we can't use numerator and denominator expression directly. First of all, we have to convert them into polynomial. For that, we will call polyfunction P1 is equal to poly numerator x P1, and in the same way we will call P2 for denominator. This is our P2. X plus 1 is P1, x plus 1. Here we will pass polynomial instance P1 and P2. And our answer is minus infinity to minus 2. This value from minus infinity is not included, minus 2 is not included, and minus 1 to infinity. These value will satisfy this rational inequality. So this is our example of how to solve rational inequality. Now we will solve a univariate inequality. Let's take the example of univariate inequality. Our expression is x greater than equal to 4, expression x square greater than equal to 4, solve underscore univariate inequality, and pass the value expr comma x. So this is our answer. 2 less than equal to x means to say कि all values for which x is greater than equal to 2. 2 means to say greater than 2, 3. 3, 9. 9 is greater than equal to 4. 2 की power raised to power 2, 4. 4 is greater than equal to 4. And x less than infinity. X is less than minus 2 will satisfy also. Suppose minus 3. Minus 3 square is 9. 9 is greater than equal to 4. So all these values will satisfy this univariate inequality equation. Our next example is solving absolute value equations. Absolute value equations, for example, x plus 7, absolute value less than 14. This is a absolute equation. When we declare the variables in Sympy, by default they are complex. But for absolute value, we have to create them real. So we here turn the real is equal to true. So our xyz variable will take now only real values. This should be done before doing absolute value equation. For example, expr is equal to, for create a absolute equation, we will call the absolute function absolute x plus 2 minus 5 expr, and x plus 2 minus 5 is, if we do not do real is true, then what happened? It will create a error. So we do real is equal to true. X plus 2 is equal to absolute value minus 5. Next, solve this expression. Solve expr. So minus 7 and 3. We have two values minus 7 and 3 which satisfy this equation. When you put minus 7 plus 2, what happened? It will become equal to, it will become minus 7 plus 2 minus 5 absolute value 5 minus 5 is equal to 0. When you put 3 plus 2 is equal to 5 and minus 5 is equal to 5 is also 0. So our equation will x plus 2 absolute value minus 5 is equal to 0 have two solution minus 7 and 3. In this way we can solve the absolute equation. Now let's check the absolute inequalities. For that, for example, our equation is x plus 7 less than 14. Let's create this equation. Equation is equal to ABS x plus 7 minus 14, less than 14, EQ1. So take this 14 to the right hand side. For that we create equation EQ1 is equal to absolute value x plus 7 minus 14 less than 0. EQ1. So this is our absolute equation, absolute inequality equation. To solve this, we will call reduce absolute inequality and ABS no need to call ABS, we will pass EQ1 comma our EQ1 is this comma, we create here EXPR so that EXPR now is less than EXPR dot REL operator, relational operator. To get the relational operator from this original equation, I have created the variable EXPR, and now shift enter, name reduce underscore, I have checked the spelling RED and reduce ABS inequality inequality and x. So this is our result. All the values where x is greater than minus 21 and x is less than 7. So if we put the value of x is equal to 5, what happened? 5 plus 7, 12, less than 14. If we put value greater than 7, that is 8 plus 7, it is not be true. X should be less than 7 to satisfy this inequality equation. In the same way, x should be greater than minus 21. That means minus 20 plus 7 is equal to minus greater than, x should be greater than minus 21. That means minus 22 plus 7 is equal to minus 15, and absolute value of minus 15 is 15. So less than 14? No, 15 is greater than 14. So we should have less than value, that is minus 22, minus 20 minus 20 plus 7 is minus 13, and absolute value of minus 13 is less than 14, that is 2. So reduce ABS inequality function we will call to solve the absolute value inequality equation. So this is our absolute value. Let's create a chart of absolute value equation. For that, general form of an absolute value function, that is linear, is equal to y is equal to mx plus b. This is x plus 7 minus 14. Here 1 is m and x, plus 7 is b, and plus c is our minus 14. Vertex of this is minus b by m, comma c. The vertical line is equal to, that is the middle line. The middle line is minus b. Now we will check graphically it. minus b by m. For example, 2x plus 6 minus 4. Here 2x, mx. So m is equal to 2 plus b plus 6. Here b is equal to 6 and c is equal to minus 4, and the vertex is minus b by m comma c, that is minus 4, and minus b is minus 6 by 2, minus 3 and minus 4 is our vertex. So we have taken a variable x is equal to np dot linspace in array from minus 6 to 0, 7 values. Let's draw the plot. First of all, define a function for this equation, our equation, that is 2x plus 6. To define the function, def keyword, name the function ab absolute, pass the variable x, and our equation return the value of y. Absolute value 2 into x plus 6 minus 4. This is our x values. Plot x label, y label, title. Our title is graph of absolute equation. Grid 2, ax line, v line. Value of y is, pass the values of x to this function, that is from minus 6 to 0, 7 values, and we will return with y. Create the chart, plt dot, create the data points, scatter x comma y comma color is equal to blue, shift enter. Okay, color is absolute is not defined, where name absolute y. Okay, I have to run it, and this is our data points. So plot, let's change the color of the vertex, that is minus 3 minus 4. We have get the vertex by the equation minus b by m comma c is minus 3 comma minus 4 for absolute value of 2x plus 6 minus 4. This is minus 3 minus 4 is our vertex. Let's change the color of vertex so that it can be clearly visible for minus 3 and minus 4. So this is our vertex. We can also create a line for this plot, and to create the line, plt dot plot x comma y. So this is our line, this is our data point, this point is our vertex, and this is minus 3 comma minus 4 is our vertex. So first of all, we have seen what is an absolute equation. For an absolute equation, we have to create the variables for which value should be real. No complex value will be accepted by the absolute equation. Next thing, we have solved the absolute equation, then we have solved the absolute inequality, and now we have created a chart of absolute function. Absolute function chart will look like this, and this will be our vertex. So in this video, we have seen the equation with radicals. We have solved the linear inequality, absolute inequality, and created the chart of the absolute values. For now, it's time to say bye. We will soon meet in the next video.